All right, welcome back, Old Man Taylor. Today's project, we're going to be talking about how to take a generator and plug that in to feed my entire house. So I've got a main panel. The main panel has a main breaker that's coming in from my utility and obviously powering everything in the house. The generator is probably not going to be able to handle that large of a load. So the concept here is I want to be able to isolate the utility so I'm not feeding power back to the utility and energizing everything. Then I'll turn off all the breakers that I do not intend to run off of the generator. But that way all my outlets will work, all the lights will work in whatever rooms on the breakers that I leave on. All right, let's get into this backfeeding idea a little bit. So my main power from my utility is coming to my main breaker. I have to be sure that I turn that off anytime I feed any power, and we call that backfeeding, into this panel. So however I do that, I've got to be sure that I cannot send that electricity that I'm feeding to these breakers to my utility. If that happens, that power is going to go through the transformer and be stepped up to that very high voltage on the lines that are obviously down. That's why I'm running the generator, which makes that extremely dangerous. Wherever those lines are down are now energized on my side. The linemen that are going to be working on that are not going to be expecting that. It can absolutely hurt people. It's illegal and extremely unsafe. So whatever we do, we must have a means to ensure that cannot happen. Well, what we're going to use today on this Square D panel, and most modern panels today have a kit that will do exactly this. Just get the one that matches your panel, okay? This particular kit, it's a pretty simple idea. It's going to bolt onto my panel. This bottom breaker in my panel is kind of upside down from traditional. Normally the main breaker would be at the top, and that would be the first breaker down on the right. Well, my main is in the bottom, no big deal, which makes this breaker right above it on the left side the one that I'm going to connect my generator to. And I already have something here, and it's already powered, and we'll have to move that, and that will become my quote generator breaker. Okay, so this block, the way that it's going to mount in here, will force this breaker to be off if this panel is on. And then in order to turn that breaker on, it'll have to slide down. Well, it can't slide down if this breaker is on. It'll have to be in the off position to clear and allow this breaker to turn on. That's the concept. That's the legal way to do this. It is a manual process. I'll have to come out and move that panel, move that plate myself, right? That makes it manual. There is an automated version of this whole thing that you can mount here that will sense that power situation and turn that on for you, or use electric switches. That's also a viable way to go. It's expensive. It's a lot more expensive. May need a little higher technical skill than what we're going to utilize today. This is completely do-it-yourself possible if you're comfortable working around electricity. If you're not, once again, always recommend hiring a certified electrician to do this work for you. But this is in the realm of DIY, do-it-yourself, if you're competent working around 120, 240 volt AC current. This is obviously in the United States. All right. So that's what we're going to do. We're going to add this plate. We're going to move this breaker. That's going to be step one. And then the second step will be adding the means to plug this in and backfeed my panel. That's the project for today. All right. So our plate's going to fit here, and we're going to go ahead and mark our panel. So when we take it off, okay, so we're going to position this kind of even with the back and in between the two breakers. With the top hole facing the front of the breaker, or the inboard side of the breaker. Mark those. Now we're ready to pull our panel and we'll drill our holes. And remember, we're going to move this breaker all the way to the top and put our new generator breaker in this spot. So we'll also have to knock out the slots for where we're repositioning that breaker. So when we're removing the main panel, we want to make sure we've got the power off from the main to the entire house. All right, then we just unscrew. We take that last screw out, supporting that panel with my arm, and now I can lift that off. Let's drill our holes here. And this drill bit did come with my kit. Okay, so my holes are here. Now I'm going to need to mount the actual switch. All right, the way that I'm going to want this to work, my base is going to obviously align with my holes, and I'm going to want the notch to cover my generator breaker. The main piece will cover my main panel. So in this case, my sticker will be upside down because my panel is reversed. Right? So the hardware that ties all that together includes a nut with a slot in it and a regular Phillips screw. What is intended here is for the nut with the large slot to be facing the user rather than the Phillips head. And that's just because we don't want someone who's unfamiliar with this whole setup to come in with a screwdriver and just remove that Phillips screw and be able to turn on both breakers at the same time. That's why that is. So if you mount it the other way, it'll still function, but that's you're defeating the purpose there. All right, I'm going to want to get all of those started before I tighten any of them down. Make sure that I have movement there. All right, at this point, use a very large flathead screwdriver to hold that. And I'm going to use a Phillips head on the other side, number 2. All right, that is called my interlock, and my interlock is now installed. So while my panel is off, the next thing I'm going to want to do is knock out my 2 blanks so that I can move my breaker to the higher position and add my generator breaker right here. We'll go ahead and do that next. You literally just twist out. One for each pole, and this is a 240 breaker double pole, so it takes up the slot of 2 breakers. All right, so our panel is now complete other than tagging. We'll tag that when we're finished, and we're ready to move our original 20 amp that was in our panel. We're ready to move that up. All right, so the first thing I want to do before I mess with any of this is guarantee I don't have power. So I'm going to check across the 2 poles. I should see 0. I do. Neutral, 0, 0. I'll go to ground just to be sure. All right, and so I know I'm de-energized now. Just want to be 100% sure of that. So I'm moving this breaker and I'm going to slide it in up here. The wire is going to be too long, which is good because we're going to trim that. If it was too short, we would have to add a splice, which we could do inside the panel legally with a set of wire nuts or something like that. But we don't need to because we have excess wire. So I'm going to start by removing my wire from the breaker. Now I only have 2 wires and I'm only going to free 2 wires, so I can't confuse them with something else. Now, like I said, I'm going to be coming up here, so I'm going to want to kind of follow that same pattern with a nice L bend in it. Doesn't matter. In this case, there's phasing, won't reverse a motor or anything like that. So if I put black on the bottom versus red, it's not a problem. It won't be an issue. All right, so I'm going to do something like that. I'll go ahead and twist those out of the way. Now I'm ready to move this breaker. The way that this is a square D, the way that this works is if I pry the front, the nose, free, the rear unsnaps. It's just, this one just snaps right in. So I'm just simply going to move that up here, put in the back first, and we're in place. So now we just want to bring those wires in just like we had them. We're going to trim that guy right about there. That guy right about there. Strip our wire. Strip our wire. Feed that back into our breaker. We'll go ahead and loosen that just a little bit more. There we go. Make sure that's very snug. Doesn't have to be extremely tight, but it definitely cannot be loose. A loose connection will generate heat. That can cause a breaker to fail prematurely, or possibly even a fire if it's really loose. All right, so we want that to be pretty snug. All right, we're ready for our new generator breaker here now that that's moved. Now we will need to relabel our panel, our schedule, to say that this breaker down here is now up there. All right, this will be our new breaker for our generator. I'm going to snap him in, and our generator breaker is in place. Okay, so our next thing that we're going to want to do is bring power to the outlet that we're going to plug our generator into. Now we've got our breaker in place. We've got to have a means to bring the power into the panel, to our breaker. So we're going to do that with an outlet that is designed for a generator. This one's 30 amp. If you've got a very large generator, maybe you go with 50. Those are the 2 most common. I'm going to have a very small generator on this setup, so 30 is just fine. So the concept here is I've got to run wire from my box to my breaker. All right, where I position this is going to depend on where I'm putting my generator. In my case, I'm right here at my garage door. So I'm going to actually mount this box inside, and the intent will be to run the cord, this extension cord that we started this talking about, right? This will make to this. I'll run that outside. My generator will sit outside, outside the garage door. So this is a very short run. Your situation may be different. If that's the case, you may want to mount this outside. This is a weatherproof box so that it can be mounted outside, and you can plug your generator right into the side of the house. In that case, I would literally just drill a hole large enough for my conduit and my wire right through my cinder block and mount this on the other side. All right, but this one's going to go inside. So my breakers here, I have all these little circles in the bottom of this panel, which are my knockouts. I have some in the sides as well, but I'm going to come through the bottom here. I'm going to mount my box, something like this, and I'll just bring that conduit around so my wire comes in nice and tight up the side and feeds my breaker and then comes down to here. All right, any wiring that I'm going to do has got to match the ampacity, the amp rating of all of my devices. So I'm using a 30 amp plug. That means my cable has to be rated for 30 amps. And that means my protection cannot be larger than 30 amps. My breaker could be a 20 amp. I won't be able to get all 30 out of it, but that would protect just fine. So smaller is okay. The same size is okay, 30. But if I have a 50 amp breaker, then all of my components downstream, the box, the wire in between, and this plug all have to be rated at that breaker rating. So when you're purchasing your breaker, make sure you're not oversizing the breaker. If anything, undersize the breaker. It gives you more protection. But anything from here all the way to my generator has got to be rated for 30 amps because I'm using a 30 amp breaker. All right, so we'll go ahead and do that. I'll take apart my box and we'll get it mounted to the cinder block and we'll run the conduit and then the wire. All right. All right, so a couple things. I've got my end for my conduit is going to fit right there. So I'm going to want to go ahead and put that on my box so I can get an idea of where that's going to be so I can position my box so the holes line up is the idea. So I don't have to tighten that down at this point. I just want to fit that. And then I'm going to look in my panel and see, you know, those wires I want to run right through here. I want them to come out this hole right there. That's the one. So I want to line that up with that hole. And it doesn't have to be exact, you know, pretty close, something like that. And then figure out the height that I want for my box. I'm going to want to set this level. And I'm going to mark my holes for my mounting screws in the wall. All right. Now, depending on your wall material here, if you have sheetrock or something like that, you're going to use different mounting. But there is some force on this. So, you know, we want to use something fairly substantial. In this case, I'm going to use a Tapcon for cement. The smallest of the versions, right? There's several Tapcon versions. I'll use the smallest. And it is cinder block. So Tapcons sometimes strip out. If that's the case, that's why I'm going with a small one. I can go to the next size. So, you know, have a few options there. The plastic plugs and anchors that you tap in would also work fine here, but that's not what we're going to use today. All right, so I've got my holes being cement. I've got to pre-drill with a hammer drill. All right, so I'll line that up. Okay, so next we're going to want to knock that out. All right, now we're ready to complete our conduit and our wire. All right, and what I've actually purchased here is a whip. This is, you know, pretty long, pre-assembled piece of conduit with the proper gauge wire for my 30 amp. Like I said, it's a bit long, but it is missing one wire. It's missing my neutral. It has 2 hots and a ground, but I need a neutral. So I bought enough white wire, which is neutral, to feed and complete this to the 4-wire setup that's required for 240 volt and 115. The whip is suitable for 240 by itself, but obviously I have single pole breakers, so I need 115 as well. In order to get 115, I'm going to combine neutral to black, neutral to red in my panel and at my outlets. So that means I've got to have the neutral from my generator in order to use that for receptacles inside the house. So I'm just going to feed that white wire through there. Don't even need to feed all of it because, like I said, this is pretty long. Now, I'm going to put a conduit fitting, which came with my whip. That's one of the reasons I got it, just because it's going to have everything that I need. But I need that power to be able to hit my breaker that I just installed from there. And that actually looks really close to the right length. So as long as I've got that much neutral, which I do, then I'm going to want to trim this so that it fits inside my conduit here. Now I want my conduit to stop here, but I need enough wire to keep going. So I'm going to go ahead and cut my conduit, but I'm going to be careful not to damage that wire because I need it to be intact to go to the switch, or to the plug rather, to my receptacle. All right, so I'm going to very gently cut that plastic, and I'm going to rotate that so that I don't go all the way through and nick the insulation of my wire itself. Be careful that you don't do that. All right, so now that's all I actually need, not very much. I've got all this excess here that I'll just take off. And I'm just holding that with my foot so that I can get the wire off. So now I'm ready to feed this through into my box and into my panel. I'll go ahead and start with the panel side. This is what that fitting looks like. I'm going to thread that. My locking ring will sit on top. You can see there's kind of a crown. The crown faces down, and that's what locks it. This is a weatherproof seal, really not necessary for what we're doing, but if this was outside, that would also be required. Right? So I want this fitting to go on before I feed that into my box. All right, and that's how that's going to go together. Now I'm going to go ahead and feed that through. And I can lock it in place. I won't hammer it tight just yet. Just want to hold it all in place for a moment. Okay, I'm just threading that on the end of that piece of conduit. Basically, I'm not locking this in because I want to make sure I didn't trim that wrong. And it looks like I did trim it just a little too long. I actually want it closer to there. So I'm going to go ahead and trim that again, but it is so short, it'll be very easy to pull the wires through and take the wire out and go ahead and cut that and see if we can get a little better fit on that. So the reason I pulled the wires out of there is just so I don't have to worry about cutting all the way through and damaging one of those connectors. All right, let's see what that looks like. Fit that on there. All right, now it looks like we've got it about right. So now I've got to feed that wire even through this bend. It's just easier to take it all apart and feed it one fitting at a time. So we'll go ahead and do that. I'm going to go ahead and tape all this together. All right, so I'm going to have a neutral and a ground. My neutral and ground are tied together in only one panel, and that is the main panel. This is the main panel, so I'll bring in one neutral and one ground into those top plugs. We'll go ahead and do that now. We're going to trim this white wire. And this is number 8 wire that I'm using for 30 amp. Okay. Bring that in. That spot right there. And we're going to need the one above it as well for our ground. So I'll go ahead and loosen both of those to make room. Slide it in. And just like our breaker connections, this doesn't have to be massively tight, but it does need to be snug. Not loose at all. Go ahead and give it that little extra. About extra is about how tight you want that to be. All right, and like I said, my ground is going to come in right above it. I'll give that a nice bend, and I'll trim that about there. Now I'm ready for my hots. Once again, it doesn't really matter red versus black, which one goes on the top, which one goes on the bottom. They need to be separate, and that's all that really matters. So those both will sit nicely just like that. All right, my black wire, sorry, my video cut out. Obviously, I did that exactly the same and tied in black. So now we're going to be ready to move down to our outlet itself, to the plug. All right, now we're ready to wire up our plug. So one thing about this is the ground for this plug is already connected here, and it'll tie in here. So we'll go ahead and complete this before we tie that in. But the ground from our panel then has got to land on the other screw right here, and that's where we're going to start. So we'll go ahead and trim this one and get it in place before we do the hots in the neutral. Now just trim that to one size too large. Okay, that gives me my ground. So we're good there. So the next one, we're going to want neutral. So how much slack do we need here? Well, we just need enough to take this apart, put it back together. We don't want it so long that it doesn't fit in the box. You know, something like that. There's no exact measurement or right or wrong here. That general area is kind of what we're looking for. So we want to strip that out. That wire. Now, the way our plug works, you know, you can see the wire is obviously going to go in there, but how does it stay? There's actually a screw through the side, a number 2 Phillips looks like, or a flathead, either one. We'll make that work. Where are we putting that? Well, we've got some very faint letters on this face. G stands for green, right? W, and I've got that upside down. W stands for white, and then I have an X and a Y. That for us will be black and red, or red and black. Once again, doesn't matter which. That just means hot, right? Back that up. Make sure that screw is loose before I start, and it was not. All right, stick our W into our screw hole and tighten that down. There we go. And now we've got our neutral in place. We can go ahead and reconnect our ground while we're working. And now our panel is grounded before we start on our hots. We want those to be roughly the same length. Once again, does not have to be exact. The general idea. And strip both of these. I apologize if that was a little lower than the camera angle. I can't quite see where the bottom is there. I'll try to remember to hold this up a little bit. All right. So before we insert our our wires. We want to loosen the screw completely. And we can see that actually kind of opens the hole there. That gate kind of slides out of the way.
Let's go ahead and do both. All right, now those are ready for our hot wires. Once again, it doesn't really matter black or red for X or Y. All right, we'll connect to that one. Get that out of the way. All right, so now it looks like we're about wired in.
Okay, once we have all of our wires in here, we're going to want to go ahead and give them a pull test. Just make sure they're tight. And there you go. There's one that's a little loose.
So let's refit that. That's why we do the pull test. All right, tighten that down. Try that again. Now we got a nice tight fit. For sure, all of those are snug.
Now, fitting all of this in here, we're going to coil that nicely. Start with the back of the box and get that lined up. Our screw should now fit.
There we go. All right, so good and snug. That locks in.
Our box now, once again, is weatherproof. Doesn't need to be, but you can hear there's an audible click there. If that was outside, that would be pretty important that we have this set up that way. I do have a light here that shows power. And what that light means is if there is power on these lugs, that will be lit. So if I turn on my main breaker and my breaker to my generator is on, that light would light up. That would be a caution that when I open these, those will be energized in that case. My interlock is going to prevent that, so that can't happen. So now the only time that light will come on is when I plug my cord in to my generator and I energize my generator and that's lit, then that light would also light, telling me that I'm ready to feed power to my main panel. Use this outlet, our plug. We've got one of the plugs has a little bit of an L in it. It's got a little notch. If we look at our prongs, one of them has got a little notch. So we're going to line that up. That's our ground. We're going to line those notches up. And once we get that in there, we're going to give it just a slight turn. If we give it that turn, it's locked in. It can't get pulled out. This particular one also has an outer lock ring to reinforce that. And it also makes it very weatherproof. Well, we're doing this inside a garage, so the weatherproof part really doesn't matter. But if you're mounting that outside, then it's a nice feature to have. Obviously, that makes it very secure. The outer lock ring really is not required, though, for generator use. Just remember, when we're going to unplug it, we have to also rotate it that little bit, and then we can take it back out. So our outlet is ready to go. Our breaker is ready to go. We're ready to remount our panel. Make sure the generator is off. When we go to do this, we cannot have, because of our interlock that we've added, we cannot have our main on and our generator on at the same time. The panel won't fit. So just remember you've made that change. All right, let's go ahead and do it. So to put our main panel in here, we're going to want to open the door and make sure everything lines up where we want it. One thing to note, my interlock, I've taped my interlock into the utility position so that I don't have it falling onto my main breaker. You may or may not need to do that. If your panel is off while you're doing this, which safety-wise it should be, that won't be a problem. But I am energizing all this for lights for YouTube, for the videos here. So I'm actually putting the panel on with my main on. So I've just taped that out of the way. Just be aware that that's an option that you may want to use if you're finding that falling onto the main breaker is a problem. If it's already off, it won't be. All right. So at this point, we're just tightening down our screws. We want to get, you notice I started all of the screws by hand before I tightened any. And that's just so I can move the panel around and get all of my screws aligned and started. If I was to start by tightening one down, I wouldn't be able to move anything to align the other screws. So go ahead and hand start all of your screws before you snug any of them down. All right. Now, this concept makes a whole lot more sense. With that breaker off, this in place, my main is holding that in place. In order to lower this, to turn that breaker on, my main has to be off. So my interlock is done. The last thing that I need to do to complete this project is add my labels, my warning labels. I need to put a label on my generator breaker, my new breaker for sure, and that'll come with the interlock kit. I'll have the warning labels to do this. I'll get one on there. And then the other thing I'm probably going to want to do is mark which breakers that I want to leave on when I go to my generator. So that way, you know, when the power's out, remember it's going to be dark, I'll be in here with a flashlight. I can turn off all of my breakers and then just turn on the ones that I marked that match the load. You know, I'm going to run my refrigerator, for instance. I may want to run my internet, you know, my modem coming in, maybe my router, may want to run the light in the bathroom, you know, those type things. So go ahead and go through that and mark each one that you want to have left on. And then don't forget, we moved this breaker. This breaker was down here, all right? So when I look at my panel, that's my dishwasher. Well, it's labeled 2 and 4 now for my dishwasher when it's really not. That's my generator. So up here where I've got these 2 blanks, that's now my dishwasher. So I'm going to want to update my schedule is what I said, right? That's what this is my schedule. So I'll want to update that. So that's how we get a generator to plug in to our main panel. My follow-up videos to this are going to be about using solar and adapting solar to fit this, basically this extension cord, and how much load we can use and how, you know, how's that going to work. If you want to see that, that's going to be the video that's going to pop up right here. This is Old Man Taylor. Hope you got something out of this video. Be sure to like and subscribe. Thank you.